Hmm.
Assalamu alaikum students, can you all hear me? Can we start? Can you all hear me, children?
Yes, miss.
Okay, right. So let's start. So as you know, children, today we are starting a new lesson, which is structure of matter. And as you already know that we have completed the unit 4 and 5 already. So once we are done with unit 3, you will have an exam on all these units. Okay, 1, 2, 3, 4, and then 5. So all these units will be included in your exam. I'll let you know when is the exam. So start preparing now onwards, right? Okay. So listen, right. So the lesson that we got to start today is structure of matter, right? We have to start the unit 3, which is structure of matter. Right? So we'll start the topic structure of matter. And children, this is the very first chemistry lesson that you learn in your grade 10 syllabus, which means this is the foundation of your journey under chemistry, right? If you want to score well in chemistry, first of all, have an idea of taking or understanding this lesson as 100%. You're going to have a complete idea on this lesson so that whatever the chemistry question you have it in the, whatever the chemistry lessons that you face in the future will be easy. Trust me, this is the truth that you have to know, right? This lesson is very important. When you study this lesson with a complete understanding, further, whatever the lessons that you have further in your syllabus, it will be manageable, right? But when you don't understand this lesson completely, you might face certain difficulties to understand the latter part of the syllabus, right? So give your focus to the 100% and start studying this lesson clearly. So let me explain you clearly so that you will understand well. Right. Now let's talk about matter, right? Now, as you know, children, there are things and non-living things, right? Let's start from the very basic for the lesson. Very basic, right? When you consider things, you can classify all the non-living things into two major categories as matter and energy, right? As matter and energy. So when you talk about matter, matter is the one which has a mass and that will occupy space. When you keep a matter, that will take up some space. That sort of a thing you call as a matter. The opposite of that is the energy. If they don't have a mass and as well as they don't occupy space, then you call that as the energy, right? For an example, sound, heat comes under energy. Matter, air, liquid, any sort of the other objects that you see from your naked eye, right? So those comes under matter. Now, when you consider matter, matter can have states of, like you call it as a physical states. Matter can have three physical states as solid, liquid, gas. That's just an idea to give you, but that doesn't involve in your lesson for today. Right. Now, children, as you see the heading, what is the heading? Structure of matter. So here you are not going to consider anything about the energy. You are not going to study about energy. You are going to only focus on matter and you are going to study the entire idea of matter. Right. Now, for an example, let's take a matter. Let's assume there is a matter. This is that matter, a box, right? You start to divide the particles of the box, which means you are cutting this box into half. Then you are further you are dividing this. And at a point, there will be a point where you can't further divide. Okay, understand clearly. Where you will be in a place where you can't divide that point further. You can't divide it, right? That point of matter you call as an atom. That point of matter you call as an atom. What is an atom? Atom is the simplest unit of a matter. Now, for example, if I can relate it to another scenario. Now, you take humans, right? Humans are complex body, right? You have several organs, several systems working at a time. You have that, this, everything is functioning, right? So that is a complex body. But when you go into deep, this complex body is made out of simple cells. They are made out of simple cells. So cells are the simplest unit of an organism. Similarly, when you take a matter, the simplest unit of a matter is an atom, right? The smallest unit where you can't further divide, or in other terms, you can tell the building unit of matter is also an atom. In other words, you can tell it that way as well, no problem. Okay, so that is the understanding of an atom. What is an atom? Atom is the simplest unit of matter. So all the matter in nature, whatever the matter that you see through your naked eye, all are made out of atom. But actually, can you see atoms? No. You can't see atoms, but it is said to believe that matter is made out of atom. Right? Now, this atom was discovered by a person who is a scientist. Right? The scientist named John Dalton discovered this. John Dalton discovered this atom. Right? Now, children, they have discovered the atom. Now, this is like a story that you have to understand the flow of the lesson. Right? Now, they got to know what is a matter. Matter are the non-living thing which occupies space and has a mass. Then they understood that, okay, this complex particles, this complex substance is made out of simplest particles called the atom. Now, they can't leave as that. Now, they are starting to investigate, or they are starting to kind of observe these atoms. They are starting to develop concepts. So, the concept which was further developed by looking at the atom, scientists stated that, children, atom is also made out of some other particles. Okay. Now, when you take an atom, That atom is made out of some other particles. That particles you call as the subatomic particles. Okay, atom is made out of subatomic particles. Let me write it. Subatomic particles. Right? Now for an example, imagine this is an atom. Inside this atom you find particles. Okay, the subatomic particles. That is the idea. Right? Now when you want to study about subatomic particles, there are three types of subatomic particles that you have to know. Okay, three subatomic particles that you have to know. Right? The very first subatomic particle is proton. Okay, the very first subatomic particle is proton. Next one is electron. And the last one is neutron. So this understanding is necessary first. This understanding is necessary first. What is that? You discovered, the scientist John Dalton discovered what is an atom. Then he stated that, okay, this atom is made out of several other particles which you call as a subatomic particles. Then subatomic particles was categorized into three major categories as proton, electron and neutron. Right? Now when you hear the word proton, remember it is made out of positive charge. Okay, positive charge. If it is electron, it is made out of negative charge. Okay, it is made out of negative charge. Neutrons are neutral, where there is no any charge distribution. Okay, proton is positive, electron is negative, and neutron is neutral. So that understanding is important. Then what you have to know? Then you have to know, children, who introduced these subatomic particles. Who came up with this idea? Okay, who discovered what is a proton? So you have to know their names for your term test exam, but not for your O-levels. Normally, until now, they have never questioned about these scientists, but better to know just three simple terms, simple names. You can remember it. Okay. So the person who discovered the proton is Ernest Rutherford. Right? Who is the scientist? Ernest Rutherford. Then the electron was discovered by James Chadwick, J.J. Thomson. And the last, the neutron was discovered by James Chadwick. Right? Okay. So come again with your idea. Did you understand this part well? Right? Listen, atoms, you know what is an atom. Atom is the simplest unit of a matter. Then atoms are divided into three major categories, which you first of all you call the particles which is accumulated inside an atom as subatomic particles. Then you have to know that there are three subatomic particles as proton, electron, neutron. Then proton is positively charged, electron is negatively charged, while neutron is neutral charge. Right? Did you understand until here? Do you have any doubts to clarify?
No.
Great. Okay. Right. Now take out the tute. Amanat, do you have the tute? Did you get the tute? I think Zainab has the tute because I sent it to the group. Do you have the tute, Zainab, as well?
Yes.
Okay, good. Amanat, do you have the tute with you or shall I send it? Send me a message to the co-host because I can't see you when you send it to the host. I think you have sent me something. I couldn't read it. Can you please send it to the co-host? Right. Do until the fifth question, children. Do until the fifth question. Okay. Do you have my number, Amanat? Can you send a message to my number? I'll send you the tute. I'll forward it. And the people who are watching the recording, who will be watching the recording, this is my number. If you don't know this number, just leave a message. Then I will be sending you the tute, because without the tute, when you don't write the answers, you will not understand anything. Okay, you will not know whether you understood the lesson or not. By looking at the screen, it doesn't mean that you have understood the part. When you attempt the questions only, you can confirm that whether you have understood or not. So once while you're watching the recording, if you come across this number, send a message with your name, so I can share you this lessons tute, this class tute, not the lessons, right? Do until the fifth question, children. Once you all are done, let me know. Done writing, children? Can we discuss the work?
Okay, miss.
Okay. How about Amanat? Have you done the work? Can we discuss? Right. So look, all the things around us can be classified into two categories defined in. So what is that? Matter, energy. Matter and energy. So what is matter? The thing that has a mass and occupy space. Right? Simple idea. Normally they don't ask you such a basic question, but I have included to the tool so that you will have understanding from the beginning. So that's energy is the thing that does not have mass and do not occupy space. Right? Okay. What are the three states of matter? As I told you, solid, liquid, and gas. Right. What is known as an atom? Come on, children, tell me your answers, please. What did you write for what is known as an atom? The simplest unit or the building unit in this. The simplest unit of matter. Right. Who discovered it? John Dalton. Okay, then complete the table. First one, the very first subatomic particle is proton. Who invented it? Ernest Rutherford. Then the next question is charge. Charge of the particle is positive charge. Right? Then electron. Next one is about electron. Right? Who invented electron? J. Charge on electron becomes negative charge. Right? Then comes the neutron. Who invented it? James. The charge is neutral charge, zero charge. Right? Okay, did you all get this answer? Did you all write these answers, children? Let me know. You have to write. If not, it's not going to be easy work, children. So this is a theory class. We are spending more time to study the theory. The past paper class, this doesn't work. Right? So here learn the theory well and then do the past papers properly in the class. So that way it is easy for you to understand and manage what you learn here. Right? So can we move to the next? Can we move to the next?
Okay, Miss.
Right. Good. Okay. All right. Okay. So now children, further we have to study. Now we know that. Now just a simple logic. Now when you discover something, when you find something, what will be your next question? How does this function? How does this work? That is the normal idea or the thought that you get when you find something new. When you find something new, you think, how does it work? How does this happen inside? How it works? That is the question that you approach, right? So similarly, earlier the scientists, they discovered atom, they discovered the subatomic particles. Now they wanted to know, how does this work? How does this function? So, what did the scientists do? Not only one scientist was there in the earlier time, no, there were several scientists. So, all started to think about each concept. So, the concept where they came up and told how does the atom works, that sort of a concept you call as the atomic model. Okay, you call as what? Atomic model. So now let's study about the atomic model. So let me erase this part so that I can take it to here. Right. Now what is an atomic model? It explains how does the atom works, the arrangement of the particles inside the atom. Where the proton, electron, neutron, how have they arranged it? Okay. So how do they work? When they have arranged only, they can be working, right? How does that happen? So that theory was explained as the atomic model. Now, maybe if you remember in your grade 9, if I'm not mistaken, you study about one atomic model called the Plum-Pudding model, which was discovered by J.J. Thomson. But in your syllabus, the O-level syllabus, you don't consider that because you know that that is a false. Okay, that is not appropriate, that is not accurate idea was not given. So they did not agree with that. They did not accept it. The other scientists. So the very first model that you have to study is about the planetary model. What do you have to study? You have to study about the planetary model. Right. Now, this planetary model was introduced by Ernest Rutherford, the person who discovered the proton. The person who discovered the proton. What did he do? He introduced an atomic model called the planetary model. Now, as the solar system works, as you know that in a solar system, in the center you find a sun. That's the sun in the center, right? So similarly, what did he do? He took a sun, saying that it is a nucleus where protons and neutrons are accumulated. That circle, that center you call as the nucleus. Then what did he tell? The remaining subatomic particle, which is the electron, will start to revolve around it. Okay, will start to revolve around it. So that explanation is the very first atomic model that was introduced. Okay, this concept where electrons will revolve around it. Right. But then children, even though it is like, okay, there is a positive and neutral charge in the center, which is a nucleus, then electrons revolve around it, even though the idea is kind of like acceptable, but there was a kind of disadvantage as well. There was no 100% satisfaction when you hear this theory, right? Because when the electrons move, there can be clashes. So they carry charges. No, these electrons or protons, they carry charges. So there can be charges clashing when this model was accepted. So therefore, as that is the reason, what did the other scientists do? They did not accept this science. They did not accept this planetary model. Okay, the atomic model was a failure. This atomic model is a failure. This is not the accepted model. Right? Why it was not? Because it was not neatly arranged, where the electrons can clash by knocking each other. So due to that understanding and that idea, this is a failure. This atomic model was given out as, like, they stated that this is a failure atomic model. Right. So then children, after they told that this is a failure, we have to have an accepted model to study now. So if not, how chemistry can grow as far as this? Now the world is full of chemistry. All the way you go, you find chemistry, chemicals, elements, everything is present. But when you don't understand this idea properly, when there is no explanation to give on this particular topic, it will not grow as this. So anyways, there should be an accepted model, a successful model. So the successful model is known as the modern atomic model. Modern atomic model. Right. Now, this modern atomic model was introduced by the scientist Niels Bohr. Who introduced this? Niels Bohr. So the scientist Niels Bohr introduced the modern atomic model. What did he tell? Actually, children, this person took some idea from Ernest Rutherford's theory. Okay, he took some idea from the Ernest Rutherford's theory, which means he developed the idea or the concept of Ernest Rutherford. He took the same nucleus where proton and electrons are accumulated, right? Around it, he told that in energy orbitals, or in other terms, the energy shells, the electron will travel. Now, children, look at this. Now it is a neat work, right? There is no any sort of clashes. There is no problems like that. So therefore, the entire world accepted this atomic model. So this is a successful one. This is what? A successful atomic model. So this is the accepted one. Modern atomic model. We believe this is how the atom works. Not this. This is a failure. Okay, we believe this is how the atom works. Right? So once again, listen very carefully. Right? Atomic models. What do you mean by atomic models? Now you know when you consider an atom, there are 3 subatomic particles. You have to know when there is 3 subatomic particles, how those 3 particles are arranged or how do they work. That idea is necessary. Right? So that idea or the description that is given on the arrangement of the subatomic particle of an atom is known as the atomic model. Right? Then in your syllabus, you are supposed to study about 2 atomic models as the planetary model and the modern atomic model. Right? When you study about the planetary model, what should be your idea, children? Who introduced this? Who introduced that? And why it was the failure? Why it was a failure? You have to know the reason behind it. Right? So the person who introduced the planetary model was Ernest Rutherford. Why it was a failure? How does this work? First of all, understand that there is a center nucleus which is accumulated by protons and electrons, proton and neutrons, right? Then electrons will revolve around it. So it was a failure due to the reason where electrons can be clashed when they knock with each other. So due to that reason, it is stated as a failure. Right. So the accepted atomic model is the modern atomic model, which was introduced by Niels Bohr. Right. So what did he tell? He took the same idea of nucleus, right? Where in the nucleus positive and neutral charges are present. Electrons will revolve around it using the energy orbitals. These are what? The energy shells, energy orbitals, anyways. You can call it in anyways. Right? No problem with that. Right? So that neat explanation was a successful one. So therefore, this is the accepted atomic model. Did you understand that? Is that clear to you?
Yes.
Right. Now, children, this is the accepted model. No, this is the accepted model. Now, when you consider the charge of an atom, now when you consider the nucleus of the atom is positively charged. Why? Because proton is there and neutron does not have a charge. They are neutral. So, we consider the nucleus of an atom is positively charged while the electron revolved around it and they carried a negative charge. So, one atom, both positive and negative, therefore, overall, the atom is a neutral charge. Okay, atom does not have a positive charge as well. They are not positively charged one as well as not negatively charged. They are neutrally charged. There is no charge distribution in them. Okay, they do carry both positive and negative. Both are present. Therefore, they are neutral. You consider atoms to be neutral. Right? Is that idea clear to you?
Yes.
Good. Right? So now take out your tubes, please. Let me share the screen. So I have attached pictures for your reference. You can have an idea. Start doing the question number 6, 7, 8. Okay, do 8, 9. That's it. Do until 9. And once you're done, let me know. Make it fast, children, and then we can have the break. After the break, we can continue the lesson. We will not be hurried to complete this lesson as it is a very important lesson, children. So focus well. We are not going to rush. I'll give you the time to understand this lesson properly and teach you well, so that you will not find any difficulties to do questions or to deal with the further lessons where you come across the syllabus, right? So better understanding is necessary in the chemistry, right? Because when you understand the concept, you can apply to any sort of questions. It is not like biology, right? Biology you have to mostly memorize or you have to have a deep idea, but chemistry is not that hard when you understand the lesson. So I'll make you to understand the lesson well. Inshallah. So do this work, and once you are done, let me know. Please write your answers on your own. Don't refer to any sort of books while you are writing your notes in the tute. Right, children? I want you to do it by yourself. So that is where you will understand whether you have understood the lesson or not. Right? If you don't understand a part, you forgot a part, just ask me, I'll help you out. But don't write it on your, don't try to do it by referring to a book. That's not an effective way of learning. And I don't appreciate you to do that. Okay. Right. Okay. So we'll discuss the work and then I'll give you the break. You can pray and be here in 10 minutes. Okay. Right. So the question is about what is known as an atomic model, right? The concept that explains explains how these subatomic particles are arranged in an atom. Okay, right. What is a charge on atom? Right. So as you know, children, they are electrically neutral. Electrically neutral. Why is that? Because the center nucleus is positively charged while the electrons revolve around it. So both charges are present on it. Therefore, they are electrically neutral. Right? Okay. Then, who invented the planetary model? Ernest Rutherford. Make sure the word Ernest is starting from a capital letter and the capital R should be included because a famous person. Right. Explain the theory of planetary model. Okay. There is a positive. Wait, let me write. Protons and neutrons are accumulated at the center of the atom, which called as the nucleus, right? Which is called as the nucleus. Right? And electrons revolve around it, around the nucleus. Right? This is the theory. All right. Then the next comes. And can you please mark the center nucleus, please? Please mark the center nucleus. This is the nucleus, okay? As well as please mark where are the electrons. Mark the electrons as well. These are the electrons that is revolving. Mark these two, please. So that you will have an idea when you just recall what you have learned. Right. So the atomic model, the modern atomic model was introduced by the scientist Niels Bohr. Okay. So the same theory, but the elaborated one, or you can call the developed theory of Ernest Rutherford is the modern atomic model. So, what did he tell? can call it as energy orbitals, or can call it as the energy shells, right? Anyways, so that idea is explained here. Okay, done. Any doubts? Any doubts until now? Any doubts until now?
No, miss.
Right. So now, children, you can have your break, right? So now the time is 5:18, right? So yes, you can have your break now and be here within 10 minutes, right? Be here within 10 minutes. At 28, break here. Okay? So you can take a break. Why? Because you deserve it. You are working for 1 hour now, go have your break and come. Be here by 5:29 p.m. Right? So have your break and we'll start by clear? Can we start the class? Can you continue?
Okay, Miss.
All right. Right. So now you know that when you consider the atoms, there is a theoretical part how it works, right? Which is the atomic model. By considering the atomic model, you can find out how many energy levels are there. In other terms, the energy orbitals or energy shells. This is the center nucleus, right? Surrounding to that, you can find the energy orbitals where the electrons will revolve. So in your syllabus, you have to study about 4 energy levels as K, L, M, N. Right? K, L, M, N. So they are very specific. They have a kind of the maximum number of electrons that they can carry in each energy level. Right? Now when you consider the K energy level, they can carry only two electrons only. Okay, more than that they can't carry. That's a maximum number of electrons that they can carry. L energy level they can carry only 8 electrons. M energy level can carry only 18 electrons and N energy level can carry only 32 electrons. Right? They can carry only 32 electrons. Above that they can't. Right? So in your syllabus you are supposed to study only until 4 energy levels. What are the 4 energy levels? K, L, M, N. K energy level can carry 2 electrons. L energy level can carry the maximum number of electrons is 8. And M energy level is 18. And N energy level is 32. Right? Then what do you have to know further? Now, when you talk about the elements, right? Now let's come to the topic elements. Right, first of all, fill this table below. Fill this part, then we can come to that point. Do that. Fill the 10th question and let me know once you're done.
Done, Miss.
Okay, right. Then let's continue with the next. Right. So now we are going to introduce to the periodic table, right? Okay. So now, in the nature, now you know when you study chemistry, chemistry is all about elements, the reaction between the chemical, and it is all about that, right? Chemistry is a study about the chemicals, the equations, and everything, the calculations, all, right? So now when you want to study this chemistry, obviously there should be elements that you have to study. They should be well arranged. You have like you can't even memorize everything. They should set into a table and like they should be nicely organized and everything should be done. So that organized table of elements you call as the periodic table. That is very important to master chemistry in O-level. Right? You're not going to study the whole periodic table. Whole periodic table contains more than 100 elements, but you are not going to study all hundreds now itself. Instead, you are going to study the very first 20 elements, right? It is easy. It is very easy. So let's study, right? So you find 20 elements in the periodic table. How many elements? 20 elements in the periodic table. Right. Then let me draw that. Okay. You start from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are the 20 elements that you have to know. Right? Now, how these 20 elements are arranged? Why have they start from hydrogen and why have they ended at calcium? Why did they arrange? What is the purpose of arranging in this order? So that is where, children, you have to know something called the atomic number. Guys, something called the atomic number. So atomic number is the unique feature that each and every element carries. Right? Now, when you consider sodium, sodium will have the atomic number of 11 and magnesium will have the atomic number of 12. What is the major difference or the uniqueness that you notice while considering these two elements? Their atomic number. They are different. They are not same. So, based on the atomic number, only the periodic table is being arranged. Okay, based on the atomic number only, the periodic table is being arranged. Right? So, let me write the numbers for all 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Right? These are the numbers. Then afterwards, you have to know when you consider an atom, you find three different particles, right? What are the subatomic particles? You find proton, neutron, and onto that revolving one is electron. Now all these three are present, right? With what number, with what addition you get the atomic number? That is, when you have the number of proton, the number of proton in the atom will give you the atomic number. Now, why did you get sodium as 11? Because 11 protons are present in the sodium atom. As for that, the atomic number of sodium is 11. Simple idea. Then what you have to know, when you have the atomic number, as you know that protons and electrons are equal, right? Protons and electrons are equal. The only difference is their charges. If proton, that is plus 11, if it is electron, that is minus 11. So out of the atomic number, what you have to understand, in order to find the atomic number, you have to know the number of proton. Right? Then what is the understanding beyond that you have to have? When you have the number of proton that is equal, the number between the difference between the proton and electron is the charges only. There is no any number difference. Charges are different, not the numbers. Right? So in that way, you can find the atomic number. Did you understand how to find the atomic number? And moreover, where do you write the atomic number? If this is the element, you write it here in the bottom. Okay, in the bottom, on the left bottom, you write the atomic number. Okay, you mention it as Z normally. Atomic number is termed as Z, right? So did you understand how to write the atomic number or to find the atomic number?
Yes, miss.
Good. Right. Then the next one is about mass number. Let's study about the mass number. Right. Now, when you talk about the mass number is the one that you are not supposed to memorize. You are not supposed to memorize. Atomic number, obviously, you have to know that, like the ascending order, the order of the periodic table will give you the atomic number. So there is no any confusions in that. But mass number, the masses are different. But you are not supposed to study to that extent. You are not necessary. It is not necessary for you to memorize to that extent in the lesson. Right? They give you in the paper the mass number for all elements. If that element is into the question, then to deal with that question, they give you the mass number. So you are not supposed to memorize them. Right. So to find the mass number you can get, children, when you have the addition of number of proton with number of neutron. When the number of proton is added with the number of neutron, that will give you the mass number. Right? Now for an example, when I have the question as sodium, I'm telling the 23. I'm telling 23 is the number of, is the mass number. And I know that the atomic number is 11. Now my question is I'm asking you, what is the number of neutron? You are supposed to find. This is a question that they can ask you in your exam. So listen. So this 11 is equal to two things. This 11 is equal to two things. What is that? Plus 11 as the proton numbers. Minus 11 is the electron numbers, because atomic number you know that is equal to the proton number. Proton number is equal to the electron number. So with that idea, you found the number of proton present in the atom and the number of electron present in the atom. Now get into this equation. What is the equation? Mass number equals number of proton plus number of neutron. Mass number they will already give you, which is 23, equals number of proton, which is 11, plus n. Subject n, 23 minus 11, which will give you what? 23 minus 11 will give you 12. So 12 is the number of proton. 12 is the number of proton. Right? 12 is the number of proton. So, sorry, number of neutron, right? So that is what you have to understand out of this. What is that? Atomic number you get when you find the number of proton. Proton number is equal to the number of electron. What is the only difference between these two? The charges, plus and minus, positive and negative charges, right? So that is about the atomic number. No? Then you study about the mass number. Mass number you will get when you add the proton number and the neutron number of the atom, right? So you mention the mass number on the left top. Left top you mention the mass number. So in a question where they have given you the mass number of proton is given, but you don't know the number of neutrons. You are supposed to find it. How do you find it? They have given you the atomic number. With that idea, you can get the proton number and electron number. So out of 3 subatomic particles, you know the 2 values of subatomic particles. The values for 2 subatomic particles. One is remaining. Get into this equation. Number of mass number is equal to proton number and neutron number. Then mass number says 23. Proton number is 11. You don't know the neutron number. Subtract the neutron, subtract the values, then get the final answer. Is that clear?
Yes.
Great. Okay, now get into the question. Do the questions in the tute. Right. Do question number 12, 11, 12, 13, 14. Do it. And yeah, do until that. Do 14. In Roman number 3, a question is not mentioned. Include the question. I'll give you the question as. I'll give you the question as phosphorus. Write down this is the question that should be added in the 14th question, Roman number 3, which is phosphorus. So the atomic number of phosphorus is 15 and the mass number is 30. You're not supposed to memorize the mass number, they will be giving you. Once you are done with this, let me know. Mention this question here. Phosphorus, that is 31 is the mass number of phosphorus and 15 is the number of the atomic, right? So this question is supposed to be added, but unfortunately it is. Add this and do it. And once you are done with the question, let me know, children. I'll discuss. Write the questions on your own. Don't refer to any sort of books. Right? Do it on your own. Friends, are you done? Can we discuss the one?
Yes.
Okay. So, what is known as the atomic number? 1 minute. The number of protons in an atom of an element. Right? Okay. What is known as mass number? The addition of number of protons and neutrons of an atom in, right? So write the equation. What's the equation? Mass number equals number of protons plus number of neutrons. That will give you the mass number, right? So now here look. Okay, I think I can write it on the board so that it's easy. So the question that says, the very first one is about sodium, right? Okay. So they have given you the atomic number and the mass number, and they are asking you to find the number of neutrons. The question that which I did earlier. Okay. Sodium, which was 23 and 11. So when you look at the atomic number, you can find the number of proton and electron, which is plus 11 and minus 11. Now you are supposed to find the number of neutrons, right? So to find the number of neutron, include the equation mass number equals number of proton plus number of neutrons, right? So 23 equals number of protons is 11 plus n. N is equal to 23 minus 11. That will give you 12. This is the first answer. Then second one. Chlorine. 35 and 7. Right? Okay. So now 17 is what? That gives you the number of proton and electron, which is plus 17 minus 17, right? The number of neutron, mass number equals proton number plus neutrons, right? So then mass number is 35, proton is 17 plus n. N is equal 35 minus 17, then n is equals 18. Right? Third, phosphorus. Okay, phosphorus is 31 and 15. This 15 will give you the number of proton and neutron plus 15 minus 15, right? Mass number equals number of proton plus number of neutron. Then with that idea, 31 is the mass number, that is equals to the number of proton, which is 15 plus n. N is equals 31 minus 15, that is n is equals to 60. Is the answers correct? Got these answers?
Yes, miss.
Right. So then, yeah. So next week we will be continuing with the electronic configuration. Then next week and the week after that, the lesson will be completed. right? Within 2 weeks, you will be completing the lesson. Then you will have the exam on first 5 lessons. Then we will be starting the unit 6, right? We will be starting the unit 6, and in between the days we will be having an exam, right? Okay. So did you understand the lesson? Do you have any doubts to clarify? Go through the tutor and let me know if you have any doubts to clarify.
No, miss.
So then that's all for the day, right? So we will meet in the next class. Until then, take care. Bye.